Hello, this is lesson 7.2, evaluating logarithmic expressions. So when we're looking at earthquakes, they use logs to figure out how strong an earthquake really is. So we use a Richter scale, but what that it really is it's always based on 10 to the power of a certain value. So we're going to use log of x to calculate each of these. So in our calculators, we're going to put log of 1, log of 10, log of 100 in our calculator. So for example, we're going to put log of 1 in our calculator and see what it equals to. So log of 1 is equal to 0. Log of 10 is equal to 1. Log of 100 is 2, and so on. So the pattern continues where this would be 3, and the reason being is it's how many zeros there are. What these really are 10 to the power of 0 is equal to 1. So 10 to the power of 1 is equal to 10. So that's how we get the x value. So this is what x is actually equal to. 10 to the power of 3 is how we get 1,000. So the power that gives us the answer is what our y value is. So it's 10 to the power of y equals x. This would be 4, 5, and then 6. So what we're going to do is we're going to use an equation to solve for the y coordinate. So there's an equation on our formula sheets that looks like this. Y equals a to the power of x. So when it's an exponential form, you would rewrite it to look like this. Log of base x, or base a, of y is equal to x. So this is how we rewrite it in log form, and that helps us solve for the exponent of, in these cases, y. So in this first example, the y value is actually our x. This 10 is our a value because that's our base, and the answer is always our y. So when we write it, we write log of a. A is 10, so we're going to write a little 10. Our y value is 81, and that equals our x value, which is, in this case, is the variable y. So when we have a base of 10, we don't have to write it. So really what we're evaluating is log of, in brackets, 81, and that's what our answer is. So in your calculator, you're going to put log in brackets 81, close your bracket, and you should get that the y value is 1.9. The next one, what we're going to do is whenever we have a value other than our base and our exponent, we're going to move it to the other side. So we're going to add 2 to both sides first. So that gives us 27 equals e to the power of 3y. Again, we're going to use this form right here to rewrite it. So our 3y is the same thing as x. So this is our x, this is our a, and this is our y. So when we rewrite it, it should be equal to log of base a, which is e, of y, which is 27, and that is equal to 3y. And to get y by itself, we're going to divide both sides by 3. So in our calculator, we're going to go to our calculator, and so if you have an older style calculator, how you're going to put that into your calculator is you're going to go log of 27, so log of the big number divided by log of e. So we have to find this little e, so it's shift, and at the top of ln is this little e, and we're going to put that the power is 1. Okay, so that would be how we calculate it, and then we're going to divide that value by 3. So this is how you do it with an older style calculator. If you have a newer style calculator like the TI-84s and up, you're going to go alpha window, number 5. You're going to put your letter E, which is shift ln, and the power is 1. and then you're going to put 27 here, and then you're going to take that answer and divide it by 3. And you should still get that 1.098, which we would round to 1.1. So y is equal to 1.1. And our last one, we're going to divide by 2 first. So first we're going to start by dividing both sides by 2. And that gives us then 10 to the power of y plus 5. That's going to give us 32 divided by 2 is equal to 16. So this is our value of y. Our 10 is our a. And this value right here is our x. And it's always in the form of log of little 10. In brackets, we're going to put 16, and that should equal y plus 5. So to get our y value, we're going to have to subtract 5 on both sides. So we're going to have to put this into our calculator as log of 16, because the base of 10 we don't have to write. And then we're going to have to subtract 5. So log of 16 in brackets. Then we subtract 5 outside the bracket, and you should be getting y is equal to negative 3.8 if we round to the nearest tenth. Example number 2, they want us to change it to exponential form. So when we have log, our little a value, and then we have our y is equal to x, we're always going to write it as y equals a to the power of x. So we're going to go in that order now. So this 6 is our a value, beside it is our y, and this is our x. So it's always going to be y, which is x in our original equation, is equal to a, which is 6, to the power of, our x value is 3. So that's what we're putting into our calculator. 6 to the power of 3 is equal to x as 216. So that's our answer. Here, our 11 is our a, this x plus 3 is our y, and this 2 is our x. So it's always going to be y equals, which is x plus 3 is equal to a 11 to the power of x, which is 2. So x plus 3 equals 11 squared, and that's equal to 121. And then we're going to subtract 3 on both sides. 121 subtract 3 is equal to 118. And that's our answer. Question C, we have log base x of 16 equals 4 over 3. So our x value is our value of a, 16 is our y, and 4 over 3 is our x. So we're going to have x to the power of 4 over 3 equals our y value, which is 16. So to get rid of the power, we're always going to take it to the power of the reciprocal. So if you have 4 over 3 as a power, if you take it to the power of 3 over 4 on both sides, those powers will cross each other off, leaving you with 16 in your calculator. You're going to take it to the power of, in brackets, 3 over 4. And so x equals 8. So this is the change of base formula. So I just want to show you how that works. So what we're doing is we're writing log of x divided by log of b. So in this case, we can write it as log of 16 divided by log of 2. Now, if we want to evaluate this with expression with technology, how we put this into our calculator, we just want to press alpha window number 5. Okay, so alpha window 5. Another way to do that is you can put log of 2 base 2, and if we write 2 to the power of 4, what I just did was I replaced 16 with a base that was the same as this base here. So these two bases are identical. 2 to the power of 4 is still 16, but the reason we do that is these cross each other off, leaving us with the power as your answer. So if you were to evaluate log of base 2 of 16, we get 4. Same thing here. In the next example, we're going to have log of 4, and then we're going to write 4 to the power of something has to equal 64. Well, I know that 4 to the power of 3 is 64, so as you can see, now that these bases are the same, they cancel each other off, and your power is your answer. This one here, we can't write negative 4 as 2 to the power of something that is equal to negative 4. That doesn't exist, so this one has no solution. And even if you tried to put that in your calculator, you would see that it does not have an answer. So here, log of base 3, we're going to write it as 1 over 27. Instead of 27, we're going to write it as 3 to the power of 3, because that replaces 27. And then log of base 3, whenever I have something in the denominator, I can always flip it and change the power to be a negative power instead. This just flips to the bottom, so these guys just flip levels, and then a 1 in your denominator does not have to be written. So just like previously, these guys cross each other off, leaving us with the power as your answer. Here we need to make this one look like 1 over 4. Okay, so we're going to write log of 1/4, and then we're going to write, first we're going to start by writing 4 to the power of something equals 64, and we know that that is 3. Now we're going to flip it by bringing it to the denominator, so that's going to be 1 over 4 to the power of negative 3. So what I did was I took that power, and whenever I flip it, I flip a value, it just becomes negative. And so these guys cross each other off, leaving us with the answer as negative 3, the power. Here, log of base 4, we're going to write it as 4 to the 1/3. So whenever you have an index, the index just goes to the bottom of the fraction, and it's still the same thing. So 1 over 3 is the same as saying the cube root, or third root of a number. So these guys cross each other off, leaving us with 1/3, which is the power, as your answer. Example number 5, we're going to evaluate this. So we're going to go log of base 2, and then 2 to the power of 4 is 16. Again, those cross off, leaving us with 4. Plus, we're going to go to log of base 2 and 2. The power, if you don't see it, is a 1. So these guys cross each other off, leaving you with a 1. Now, since we have addition between them, we have to add the two answers, and we get 4 plus 1 is 5. Log of base 2, 2 to the power of 0 actually equals 1. So that's how we replace this value right here. 2 to the power of 0 is 1. Then log of 2, we would write it as 1 over 2 to the power of 3. That replaces 8. So these guys cross each other off, leaving us with 0, but we still need to work with the other side. Log of 2, whenever we want to flip the levels, we would write 2 to the negative 3. So that's how we bring that to the top of the fraction. That way they're the same and they cross each other off, leaving us with 0 minus negative 3. 0, 2 negatives becomes positive, so we're going 0 plus 3, and that's equal to 3. Example number 6, they're giving us an equation where P of x represents the pH of a solution. So this is our pH, and this is our concentration. So in this first case, they're giving us the concentration, which is our x, so we're solving for P of x. So we're going to put that into our calculator by replacing x with 0.0001. So in your calculator, you're going to write negative log. In the brackets, you're going to put 0.0001, and that gives you 4. So that's the pH of the solution that they're giving us. In the next one, they're giving us the pH of 2, so that's your P of x. P of x is going to be replaced with 2. So 2 equals negative log of, we're trying to solve for this x now. Step 1, we need to bring the negative to the other side of the equation. So it's going to be -2 equals log of x. The base, if you don't see it, guys, is a 10. So the 10 is always there. This is our x, this is our a value, and this is our y value when we're writing it. So it's always going to be y equals, so x equals a to the power of x. So that is our concentration. So if you go 10 to the power of -2 in your calculator, you're going to get that the concentration is 0.01, and that would be in moles per liter. Now we need to compare two solutions. When we compare them, we always write them as 10 to the power of the negative pH of one versus 10 to the power of the negative pH of the other. So we're going to write 10 to the power of one of the pHs they're giving us is 1.6. So we're going to write -1.6. And the next one is 10 to the power of -2.5. Now we need to figure out which one's bigger. This one is bigger. The less negative a number is, the bigger it actually is. So even though it looks like it's smaller, -1.6 is larger than -2.5. So this one is bigger. Always put the bigger one at the top. So you're going to divide them by putting 10 to the power of -1.6 over 10 to the power of -2.5. So you're going to put that into your calculator. So 10 to the power of -1.6. And you're going to divide that answer by 10 to the power of -2.5. And you'll get 7.9. So we know that this is to the nearest tenth. So we know that solution A is 7.9 times stronger than solution B. Because this was solution B and this was A. So the A was at the top, which means it's stronger. Next one, we're doing the exact same thing. They just want our answer to the nearest whole number. So we're going to take one pH, which is 10 to the -8, and the other pH, which is 10 to the -12. So we always put the negative in front of the pH. And we're going to take the bigger one, which is the -8, over the smaller one, which is -12. You're going to divide them in your calculator. And you're going to get 10,000. So we know that seawater is 10,000 times more acidic than soapy water. Okay, so that's how we go. That's how we compare them. In our next one, they're giving us the answer. They're telling us that the answer is 500, and they're asking us to compare two solutions. Well, they're telling us that one pH is 6.1, and we need to find the pH of the conditioner. So the hair conditioner that Alana uses is 500 times as acidic as the shampoo she uses. So find the pH of the conditioner. Okay, so we want to compare these. So what we're doing is we're saying that the conditioner is less acidic than the shampoo. So we're going to put, so the hair conditioner that Alana uses is 500 times as acidic as the shampoo. So actually the conditioner is stronger. So we're going to go 10 to the power of negative conditioner, so that's the pH, divided by 10 to the power of the shampoo she uses, which is -6.1. So what we need to do is solve for this conditioner value. So we're going to multiply both sides by 10 to the power of -6.1. Okay, so once we have that, we can put this part into our calculator. So 500 times 10 to the power of negative 6.1. So we know that that would be equal to 3.97 times 10, because that's e to the power of negative 4. Next thing we're going to do is we're going to write this as log. This is our a value. This power is always your x value, and this is your y. So we need to write in log form by writing that our x value is equal to log of base 10 of our answer, which is y, 3.97 times 10 to the negative 4. So in your calculator, you can ignore the base of 10 because that is always assumed. And we know that this is a negative x because that's our negative conditioner. So we have log of 3.97 times 10 to the power of negative 4. So we're going to get that negative x equals negative 3.4, and then we're going to divide both sides by negative 1. So the pH of the conditioner is actually 3.4. Okay, so that